In this lesson, we are going to discuss about nitronium ion. Nitronium ion has two oxygen atoms and it has positive charge. So let us count the number of valence shell electrons. There are two oxygen atoms. They will use 6 electrons from each and 5 from nitrogen. So here, since there is a positive charge, we have to subtract 1 electron. So it will add to 16. So we can add the electron first for the two oxygen atoms, and we have used all the 16 electrons because there are 8 plus 8 will add up to 16. So there are no any electron remaining for use of nitrogen atom. So then we can check whether the nitrogen atom has completed the octet. Now nitrogen has 4 electrons now, so it needs another 4 electrons to get the octet. So we can use these two lone pairs and it will result this ion. Now we can count the charges. I will name 1 and 2, 1, 2 and nitrogen atom. So they have 6 in valence shell. Nitrogen has 5 and here 6 electrons belong to oxygen atom number 1 and here again 6 electrons and here 4 electrons, because 2 double mode means we count only half of from that electrons. 2 plus 2, 4. So we can simplify 0, 0 and plus 1. So that plus 1 should go to the nitrogen atom. Now we can consider the oxidation number of these 3 atoms. When we come to oxygen atom number 1 and 2, they have the same configuration in bonding, so they should have same oxidation number. So oxygen is more electronegative than nitrogen, so that oxygen atom can withdraw the electrons in that double bond towards itself. So then oxygen atom will get the negative charge and nitrogen atom get the positive charge. Since there is a double bond, O1 and O2 gets minus 2, because here this oxygen atom feels extra 2 electrons come to its valence shell because of this withdrawal process. Now when we consider nitrogen, nitrogen feels the opposite. Nitrogen feels 4 electrons will lose from itself. So it should get plus 4, but there is already plus charge in nitrogen. That means nitrogen has lost 1 electron here. So then altogether nitrogen oxidation number should be plus 5. Now we can come to the geometry of the molecule. It has 2 PaCpR pairs on the nitrogen atom and no lone pairs. So the geometry should be linear because no repulsions come from any lone pair electrons. So best orientation is linear. So 180 degree between these two bonds. Now we can discuss the hybridization. In previous videos I have discussed the hybridization in detail, particularly for oxygen atom with double bond. So in this oxygen atom number 1 and 2 has similar bondings, 2 lone pairs and 1 sigma bond. So it requires 3 hybridized orbital. So these two, oxygen atom number 1 and 2, can achieve that using sp2 hybridized orbital because it has 3 hybridized orbital. So when we consider nitrogen, nitrogen doesn't have any lone pair. But it has to complete 2 sigma bonds and 2 phi bonds. And also there is a positive charge. So we will discuss that in detail. When we consider the ground electron configuration of nitrogen, it has 5 electrons in the valence shell. But when we come to here, there is a positive charge. So we have to rearrange that configuration so it matches with this situation. So we will remove this electron because it is easier to remove coupled electron than uncoupled electron. And also here there is a maximum parallel spin, so I will discuss those separately in another video. In this situation it has 4 electrons in the valence shell. So let us see how to get this requirement. Now we have to have 2 sigma bonds. So that we need 2 hybridized orbital. So then I can use one from S and one from P. So let us see SP. So these SP orbitals should be in between P and S sub-energy levels in terms of energy. So there are remaining 2 electrons with P orbitals. So we can use those 2 electrons for phi bonding. Okay. So then the hybridization of this nitrogen atom is sp, and hybridization of O1 and O2 is p